Hi folks, Tom McNamara back again for our course in trigonometry. In this video I thought I would just summarize the information about graphing trig functions. So these kind of basic schemes here are what I want you to look at. So the amplitude is always given by the multiplier a. Now remember, amplitude is always positive. If your multiplier is negative, we'll take the absolute value to get the amplitude. So maybe I'll even put that in here. It's absolute value of a, that's the amplitude. If your multiplier is negative, you're going to get a vertical reflection. So the normal sine function starts at the midline, goes up top. If you have a reflection, you'll start at the midline and go down. Period, this multiplier is related to the period. You got to take 2 pi divided by that number. Out here is where you get your vertical shift. If k is positive, you'll get shifted up. If k is negative, you'll get shifted down. And in here, that's where you get your horizontal shift. If it really is x minus something, that'll move your graph to the right. If h is negative, so that it becomes x plus something, then you'll move to the left. Okay, so just by looking at our formula, we get this information. And then, when we have this information, we can draw our graph. The previous 2 videos discuss several examples of doing that. But here, I want to go the other way. Okay, so this is our key idea for this video. Getting the equation from the graph. Getting the equation from the graph. Okay, let's look at a quick example. So here's a graph. Let's try to work out what the equation would be. Alright, so I'm looking at this. I'm looking at problem number 12 right here. Okay, so I'm seeing, okay, the cycle starts at 0 and it ends at 2 pi. Okay, easy enough. I'll pencil some things in here. So my period, the period of my graph is 2 pi. My amplitude, well, I'm seeing my midline is right here. I'm going 2 units above, 2 units below. So my amplitude is 2. And notice I start at the midline, I go up, down, bottom out, back up. Okay, that's a sine function. Sine starts at the middle. If I was looking at this one, I start at the top. I'm thinking, okay, that's a cosine graph. This is a sine graph. Okay, so I want an amplitude 2, period 2 pi sine function. Easy enough. The formula for that would be y equals 2 sine x. Okay, so it's basically just doing the graphing business in reverse. We can look at the formula and extract the key information for the graph. Well, we can look at the graph and figure out what we need for our formula. Period 2 pi means the multiplier in front of x should just be a 1. Amplitude 2 means we have an outside multiplier of 2. No horizontal or vertical shift. So we're done. 2 pi x. Let's look at this one right here. Okay, here we got to change to the period. Notice my cycle starts at 0 and it ends at pi. Okay, the period is pi. Amplitude is 1. And this will be a cosine function. Now, if I want my period to be pi, that tells me what b is. So 2 pi over b is equal to my period, which is pi. I can solve this for b. And you're going to get b equals 2. Okay, so that graph that we just looked at would be cosine 2x. Okay, once again, look at the key information here. Amplitude 1, so the outside multiplier will be 1. Period pi, that's where we're getting this. That multiplier needs to be a 2, and it will make the period of the function pi after we do 2 pi over b. Okay, if that value of b were a 2, the 2's would cancel and you get a pi, which is what we want. How do I know I'm dealing with cosine? Well, the graph starts at the top of a cycle, and that's the pattern for the cosine. Top to the middle, bottom out, back to the middle, up top. Okay. Let's do 1 or 2 where we have some shifting. Some vertical shifts, some horizontal shifts. Okay, let's look right here. Looking at problem number 28. Okay, let's get the graph. Well, okay, if that were the question, then we're done, right? Let's find the equation. Period. Okay, well, once again, we have to refine our idea of what the period of a function is. The period is the length of one complete cycle. A lot of people would be tempted to say, okay, I see 9 pi over 8, that's the period. No, that's not right, because the cycle starts at pi over 8. So what we got to do is 9 pi over 8 minus pi over 8. That's the length of one complete cycle. Okay, and we can see here that actually works out to be pi units. So you got period pi, a horizontal shift, pi over 8 units to the right. You want the amplitude to be 2. Let's put all that together. Remember, this is the scheme we're thinking about right here. I guess it's this one because that was a sine function. Okay, so vertical shift, don't have to worry about it for this one. Amplitude 2, okay, make that a 2. Period pi, make the b a 2. And then the the horizontal shift of pi over 8 units. So, for the graph that we just saw, and let me just maybe draw some lines here to separate everything. Y equals 2 sine 2 times x minus pi over 8. Okay, we're just looking at this scheme and we're filling in the details that we have gleaned from the graph. So we can look at the formula and get the information to draw the graph, or we can look at the graph and get this information and put it into the formula. In this case, we're getting that. I suppose we could, if we wanted to be clever, we could do that. Where's the pi over 4 coming from? We'll multiply through. Notice there are no parentheses here anymore on the inside. No brackets. So distribute 2x, 2 times pi over 8. The 2's cancel, leaves you with a 4 down there. Okay? So, once again, we can look at that graph and figure out the important information that we need. Okay? We can get the period by looking at where does the cycle start and where does the cycle end. The difference between those two values, that's the period. Let me look at one right here. Here's one that's a little tricky. I'm going to add in this extra little dotted line. Okay, that's the midline. This is a shift, a vertical shift, down 2 units. Okay. Now, gosh, I gotta think here. I'm seeing 1, 2, 3 complete cycles in this picture. So that's 3 complete cycles between minus pi and pi. Well, if I go from minus pi to pi, that's a distance of 2 pi, but that was 3 complete cycles, so my period is 2 pi over 3. So I got a vertical shift, I got to change to my period. I'm starting down here at the bottom and going up top, so that means I should have a negative multiplier out front to get a vertical reflection. Okay? So, in fact, I'm just going to write it right here. A very, these pens actually erase, so, oh gosh, I hope they do. Ah, okay, they kind of do. Okay. Okay, so, got a vertical shift of 2 units down. Okay, so y equals, I'm going to have a negative 2. Now the amplitude, notice here's amplitude's also 2, because I'm going 2 above, 2 below. Minus 2 cosine, period of 2 pi over 3, I'll need a 3 here. Why is this negative? Well, for normal cosine, we actually start at the top of a cycle and come down. Here we're starting at the bottom going up. Okay? So that's why I have a negative here. Negative 2 gives me the shift of 2 units down. This gives me the reflection. There's my change in amplitude. There's my change in period. Okay? So I'm looking at the picture, and I'm seeing all the key information in the picture. And then I'm putting that into my formula. Okay, so remember, we've got these skeletons here, these schemes. And the schemes work both ways. If you can look at the formula, you can tell the vertical shift, the amplitude, use that to change the period. There's your horizontal shift. And now you can draw your graph. If you've got the graph, you can work it backwards. From the graph, you can tell the vertical shift, amplitude. You can figure out B because the graph will tell you the period. And then you can also figure out where does the cycle start. That'll tell you if there is a horizontal shift. So you can get all that information from the picture and then plug that into this scheme and get the formula. Okay? So we can work these problems both ways.